Neuroplasticity is the brain's ability to reshape and even heal itself. Neuroplastic phenomenon were considered rare, and a lot of people doubted the phenomenon existed at all. But Eric Kandel was one of the first to demonstrate that learning produces neurostructural changes in neurons. However, it was really the pioneering work of Doidge in the introduction of neuroimaging techniques, which has really turned the field of neuroplasticity into the area of intense study it has become. The most compelling aspects of this research show there are direct morphological changes on brain regions associated with use. Humans demonstrate the ability to regulate their behavior towards learning. And this feature of regulation is conscious, effortful, and it allows for goal-directed control, which produces an identifiable physical morphological change in the brain. For example, a study of London cabbies by McGuire et al. Demonstrated that as cabbies come to memorize all of the streets and the roads in London as required for their job, a measurable anatomical change occurs in the size of their hippocampus. While this study is generally cited as evidence for hippocampal role in memory formation, it is also evidence of metacognitive self-regulation affecting brain plasticity. This effect is not limited to memory. There have been demonstrated impacts on the brain's linguistic areas during language acquisition. The most widespread neuroplastic effects were actually found in studies of students learning to play musical instruments. A similar form of metacognitive self-regulation is involved in the act of physical fitness. Through a conscious process of metacognitive self-regulation, what is practiced becomes habituated and physically affects all areas of the body that are involved in that process, producing changes to those targeted areas. By virtue of this interaction, humans can develop their physical brain in much the same way that they can develop their physical body or really any practicable kind of skill. Research into neuroplasticity suggests that humans can counteract and even stave off the effects of disability if they are able to harness their self-regulatory behavior through metacognition. And there are many examples of individuals using their personal powers of metacognitive regulation to identify ways to rise above a disability or adversity. It's been found that physical interventions like exercise routines actually trigger the production of brain-derived neurotrophic factor and other growth factors that stimulate neurogenesis in the growth of new nerve cells. These neurological compounds have been shown to increase the resistance to brain insults, improve learning, boost mental performance, and affect conditions that can lead to both muscle and brain impairment. The knowledge of brain-derived neurotrophic factor and the beneficial effects on physical fitness have even changed the way surgeons and physical therapists interact with their patients. After most modern procedures, surgeons rarely require more than 48 hours bed rest. In fact, most require immediate physical therapy. Along with targeted therapeutic exercise, the goal is to expand the patient's metacognitive knowledge about the brain to positively impact their self-regulatory adherence to these restorative therapeutic routines. So even here, metacognitive regulation plays an important role in the physical and neurological healing that is made possible by learning and exercise.